We're going now to predict the number of products of, say, monochlorination products of a different structures. Remember that we said that chlorine is more reactive than bromine in radical reactions, and thus it will be less selective. So you will have typically a mix of products. So I'm going to draw structures here. Let's make it easy at first. So this one, this is just butane, right? This place is identical to that. That will form primary radicals. So, okay, let's just draw that radical. And we know that that will be identical to that. And we have six hydrogens that are primary in this structure, 3 and 3. And now we have another position, let's call that A. And so this is A as well. And we have another position here, this and that, those are identical. So B and B. So we will have two products. So forming the radical, that position will lead you to this, and that's secondary. We have two hydrogens here and two hydrogens there. So we have 4 hydrogens that will lead to a secondary radical. So what are the products coming from that? So if you have the substitution here, then the primary products would be the following. For example, I'm talking about monochlorination, so let's write that down. Chlorination, because remember, it's more reactive. That's the one that will lead typically to a mix of product. The product of the substitution of one hydrogen at the other position is the following. So you will have two products in this case. Now let's talk about another structure, a bit more atoms now. Here. Now, analyzing that structure, there is symmetry at the center. This carbon is identical to that, so it will lead to, say, the same products. I'm going to call that A. And because of symmetry, this is A and A, so same product. Now I have another position here. This one and that one, let's call that B. And lastly, we have another position here in the center. There are two hydrogens there. We're going to call that C. So we will have essentially 3 products, A, B, and C. So I'm going to draw the radicals first. So remember that all of the A positions will be the same. So I'm going to do that. These are primary, and you have 6 and 6. You have 12 hydrogens that are primary, and the product will be the following, right? So we are replacing one of the hydrogen by a chlorine. That's a primary product. Now, the other radical that you would form is, say, when you remove the hydrogen at B, and that will form a tertiary radical. So this would lead to the following radical, this one. And you have here 1 hydrogen and 1 hydrogen. So this is 2 hydrogens that are actually tertiary. And so the product of that is, again, you're replacing the hydrogen. So this is your product. Lastly, you can also remove one of the hydrogens here. You have 2. And let's do the arrow, small arrow over to that side. Now you're forming a radical here. That radical is secondary, and you have 2 hydrogens. So we have here 2 hydrogens that are secondary. What is the product here? So you're going to replace one of the hydrogen by a chlorine. So this is it. So here you have 3 possible products. Even though we have many more atoms, there is symmetry in the molecules, so there were positions that are equivalent. We're going to be doing more of that. So this is just predicting the number of products. And here we're using monochlorination, so replacing only one hydrogen by a chlorine. in chlorination because that's a reaction that will lead to multiple products typically.